Hello and welcome on the section on Hamiltonian cycle using backtracking. My name is Albert Sebastian and today we are taking a look at what this concept is all about. So looking on the agenda of today, first of all we will see the introduction. Secondly, we will move on to some key factors regarding the Hamiltonian cycle. Then we will see the pictorial representation, that is how to manually solve those problems. After that we will straight forward to the Hamiltonian cycle using backtracking. Moving on to the section, we will see the algorithm. A Hamiltonian cycle is a closed loop on a graph where every node, that is a vertex, is visited exactly once. I repeat, it's a closed loop. A loop is just an edge that joins a node to itself. Backtracking. It's a technique based on algorithm to solve problem. It uses recursive calling to find solution by building a solution step by step, increasing values with time. It removes the solutions that doesn't give rise to the solution of the problem based on a constraints given to solve the problem. Here is some key factors of Hamiltonian cycle. The first concept is that if a graph is given, we have to start from some starting vertex and visit all the vertices exactly once and return back to the starting vertex so that it forms a cycle. And the second thing is that find any Hamiltonian cycle is possible in the graph. If possible, what the cycle is. If there are multiple cycles, then we have to find all those cycles. So here is some additional information that when the Hamiltonian cycle is not possible. The first thing, when a Hamiltonian cycle is not possible, if a graph is a disconnected graph, that is there is not exist any path between at least one pair of the vertices. And the second thing, when it is not possible, of a graph containing an articulation point in which that particular vertex and associated edges are removed, it becomes a disconnected graph. And the third way is a graph is containing a pendant vertices, that is the vertex having a degree 1, that is the end vertex. Before moving to the actual backtracking process, let us solve the problem of Hamiltonian cycle manually. Here in the given graph, we have to consider a starting vertex, and from that starting vertex visit all the vertices at least once and return back to the same starting vertex. Here we have a graph of 6 vertices. Let us take the starting vertex as vertex A. From we have to visit all other 5 vertex exactly once and return back to the same starting vertex, that is A. Also, all such possible cycles should be identified. Considering the cycle, we can see that there is a path between A, B, C, D, E, F and back to A, in which it visits all the vertex exactly once and return back to the A. Now we have to find all the possible cycles. So considering the another path A, C, D, B, F, A also satisfies that it visits all the vertex exactly once and return back to A. The other possible cycle is A, B, F, E, D, C, A. From the given graph, we can perform backtracking to find the Hamiltonian cycle. We can start with any random vertex. Let us start with the vertex A. Neighbors of A are B and E. It's a depth first search, so we take B as our vertex. The adjacent vertices of B are C and D. Since it follows the depth first search, we choose the C. Then there is a path from C to D and D to E. Now it forms a cycle because from E we can move back to the starting vertex. So it forms a Hamiltonian cycles, namely A, B, C, D and E. We have to find all possible cycles, so we used to backtrack. We cannot explore any more path from D, so we used to again backtrack and again. From B there is an alternative path from both C and D, so we can choose D as our vertex. Then we have two paths, that is E and C. We choose E, C, and it's a dead end because there is no any other path, so we backtrack. Then we visit vertex C. The vertex C is not been visited, so it's a dead end, so it doesn't form a Hamiltonian cycle. So we used to backtrack again, back to D, then back to B, then back to A. From A there is an alternative path to E, so we choose E. Then there is a straight path to D. Then from D we can move two ways, either to the vertex B or to C. Let us move to the vertex B, but the Hamiltonian cycle is not at all possible there, because after visiting the C there is no any other way to return back to the starting vertex A, so we backtrack. So from D we can visit directly to C, then B, then there is a returning path to the starting vertex A. So it follows a Hamiltonian cycle, namely A, E, D, C and B. Algorithm for Hamiltonian cycle using backtracking. The algorithm contains of two parts, algorithm Hamiltonian and algorithm next value. First, let us discuss about the algorithm Hamiltonian. This algorithm uses the recursive formation of backtracking to find all the Hamiltonian cycle of the graph. It generates a value of x of k, next value k. It assigns a legal next value to x of k. Now the control moves to the second algorithm, algorithm next value, in which x of k equal to x of k plus 1 mod n plus 1. It is used to determine the next value. If x of k equal to 0, then return. The graph is represented in the system in the form of an adjacency matrix. If there is an edge, it will be denoted as 1, and if there is no edge, it will be denoted as 0. If x of k equal to 0 means whether there is an edge between them. If there is no edge, it should return. If x of k minus 1 and comma x of k not equal to 0, that means there is an edge present. For x of k equal to 1 to k minus 1, do if x of k equal to x of j equal to x of k, then break. Each check is there is any duplication, that is already taken value should not be taken. If j equal to k, then if k less than n or k equal to n and g of x of n comma x of 1 not equal to 0, that it check whether it is in last position. If it is last position, then return back, is there any edge that return back to the starting vertex. If it is, then it is a condition that follows the Hamiltonian cycle, and then it return and it follows all the condition. Now control come to if x of k equal to 0, then return in Hamiltonian algorithm, in which it check if it is 0, that is there is no node possible, then it return back to previous node, that it backtrack to the previous node to find any other possible value. If k equal to n, then return x of 1 is to n, else Hamiltonian k plus 1. That is, if it is of nth position, then write the Hamiltonian cycle, it is the cycle, or else it continue to track the numbers, that is possible. Thank you.